Good morning, class. We are looking at exam 1 review covering from section 1.6 to 3.1, sequences and difference equations, limits of sequences, limits of functions at infinity, limits of functions at finite numbers, algebraic methods, derivatives, and rates of change. When you take the exam, I want to emphasize that you take the exam on your own, although there is no proctorio. Imagine you take the exam on campus, and there's a pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam, and the rest of them as well. So that's important. You can't use any help, no PowerPoints, no index cards. You may use a scientific calculator. Most of these questions are either from the lecture or the exam review that you can find it under Canvas Module 1. So here's from exam review. Find the general term for the following. And this is as complicated as it gets. There are three parts here. Notice the sign changes. It alternates positive, negative, positive, negative. Then the numerator, then the denominator. And when we are done, it will look something like this. So first and foremost, as far as the sign is concerned, for alternating sign, we use one of these two, negative 1 to the power of n, or negative 1 to the power of n minus 1. By the way, n plus 1 results in the same thing. So which one and why? All you have to do, plug in 1. If you plug in 1, negative 1 to the power of 1 is negative. The first one is positive. But over here, negative 1 to the power of 1 minus 1 is 0. Negative 1 to the power of 0 is positive. So this is the one we use because the first one has a positive sign. Then you write out the numerators. 6, 10, 14, and the rest of them. Notice this is an arithmetic sequence. Why is that? Because the first term we add 4, the next one we add 4. So a sub 1, the first term is 6, and d, the common distance or difference is 4. So we use the general form a sub n is a sub 1 plus n minus 1 times d. Plug in, and we get 6 plus 4n minus 4. These two numbers, they add up to 2. So the final answer is 4n plus 2. And we move on to the next step, namely the denominators. Notice this is a geometric sequence. Why is that? This is the first step. Times 3 is 9. Times 3 is 27. Therefore, a sub 1 is 3, and r, the common ratio, must be 3. Therefore, we use a sub n equals a sub 1, which is 3, times r to the power of n minus 1, which is 3 to the power of n minus 1. And the product rule of exponential says a to the power of m times a to the power of n is a to the power of m plus n. So we're going to add the exponents. One of them is 1. One of them is n minus 1. And the sum of the two is n. And therefore, we are going to put this together. This part, negative 1 to the power of n minus 1. This part, 4n plus 2. And this part is 3 to the power of n. Now, what is the next step? As always, when you come up with the general term, you must check. So if I replace the n with 1, negative 1 to the power of 1 minus 1, that is negative 1 to the power of 0 over 1. 4 times 1, 4 plus 2 is 6. 3 to the power of 1 is 1. So we get 6/3. That's the first term. I check the first term, but always check more. Check at least one more to be on the safe side. We want to find the first 5 terms of the sequence. This is from the lecture. So if I plug in 1, I get 2 to the power of 1, which is 2 minus 4 is 2. If I plug in 2, I get 2 squared. 4 minus 4 is 0. If I put number 3, I get 2 cubed. 8 minus 4 is 4. And you can figure out the rest. Find the first 6 terms of the recursive sequence. A sub 1 is 1, A sub 2 is 2, and A sub n plus 2 is A sub n plus 1 plus 2 A sub n. We have 2 terms, we need 4 more terms. So what does this mean? When you look at this, it means if I want a term, A sub n plus 2, I go to the previous one, A sub n plus 1 is before that. And then I go to the previous one before that times 2. So if I want A sub 3, in fact, you can even say, okay, if I want this to be 3, then n must be 1. So replace it here. You get A sub 3 equals A sub 1 plus 1, that means A sub 2, plus 2 A sub 1. A sub 2 is 2. 2 times 1 is 2. They add up to 4. And obviously, following the same methodology, A sub 4 is A sub 3 plus 2 A sub 2. A sub 3 is 4. A sub 2 is 2. 2 times 2 is 4, and 4 is 8. So 2 were given, 2 I calculated, and you can do 2 more on your own. Finding the sequential limits. To find limits, simply plug in and observe. So that's what we are going to do here. 2 to the power of n as n approaches infinity. It is infinity and therefore diverges. Why is that? Here's the theorem we should be comfortable with. The limit of r to the power of n as n approaches infinity, it depends on the value of r. If it's between -1 and 1 becomes 0. If it's 1 becomes 1. And if it's larger than 1, as it is the case here, goes to infinity. Part B, plug in. 2 to the power of negative infinity is 0. The answer is 5, and therefore it converges. Now, why is this 0? Because a to the power of negative m, negative exponential rule says it's 1 over a to the power of m. So this is 1 over 2 to the power of infinity, which is 1 over infinity, which is 0. Last part, if you plug in 1 over infinity becomes 0, the answer is 1, and it converges. However, you can either do that or remember the theorem. The limit of 1 over n to the power of p as n approaches infinity is 0 as long as p is positive. In this case, p equals 1. The exponent on n is nothing. That means 1. A rational expression and n is approaching infinity. Obviously, if you plug in, you get infinity over infinity, which is an indeterminate form. The technique, whenever we have a rational expression where n is approaching infinity, is to divide by highest degree term in the denominator, namely n squared, and simplify. As n goes to infinity, this piece, this piece, this piece, and this piece, each one goes to 0. 2 over 5 is the final answer. Express 0.46 bar as a rational number. We are going to use the methodology of geometrics sequences and geometric series, although there are other methods algebraically. So first, this is a repeating decimal, 0.46 and 46 repeats. So we have this part, 0.46 or 46 over 100. We have this part, which is 0.0046 or 46 over 10,000. We have this part, and we can write them either in a fractional format or a decimal format. And I'm going to look at both cases. Understand that we are looking at the geometric series because we are adding up. And so what happens is, here's our first term, A is 46 over 100 or 0.46. You don't have to simplify it for a reason. I want you to see what is the first one. And R, notice this is 100 squared or 10,000. This is 100 times larger than this, which makes the fraction 100 times smaller. So R is 1 over 100 or 0.01. And because R is between -1 and 1, we can use A over 1 minus R. And we are going to do that both with fractions as well as decimals. So this is the first term, 1 minus 1 over 100, or the first term is in the form of a decimal. Now, if you look at the fraction, it's a complex fraction, which means you have to multiply by 100. So you're going to multiply the top and the bottom by 100. When you multiply the top by 100, you get 46. When you multiply the bottom by 100, you get 100 minus 1, which is 99. And if you look at the decimal format, 0.46 at top, 1 minus 0.01 is 0.99. And obviously, if you multiply by 100, the top and the bottom, you get to the same answer, and you're done. Now, this is from the exam review, and this is slightly different than what we have seen. And what is the difference is that the only part that is being repeated is number 6. So you have 3.1 and this part that we are going to work on. You could write this as 3.1 plus 0.0, and then the bar is at top of 6 only. You can write it in the form of a fraction or a decimal. Now, what I want you to notice is this. So when you write it, this one is 6 over 100 or 0.6. The next one is 6 over 1,000 or 0.006 and so forth. So this number, 1,000, is 10 times this number, which makes this fraction 10 times smaller. So you're dealing this part. You're dealing with the geometric series. Here's the first term, A, and R is 1 over 10, which means because it's between -1 and 1, I can use A over 1 minus R. So this is 3.1 plus this part using A over 1 minus R. So, and of course, let's write the decimal format as well. So if you look at the complex fraction, you multiply the top by 100, you multiply the bottom by 100, and so this one remains. This becomes 6, this becomes 100 minus 10. Please understand, this remains the same, 6 over 100 minus 10, and I can't emphasize this enough. Now let's look at 100 minus 10. which becomes 90. So 3.1 plus 6 over 90. And now I want to look at the decimals. The decimal format, the numerator is 0.06. The denominator is 1 minus 0.1 or 0.9. Notice if I multiply the top and the bottom by 100, I get the same thing, 6 over 90. And that's really the key that I want everybody to pay attention to. All right. So now 6 over 90, if we want to add them up, an easy way, 0.1 is 1 over 10, 6 over 90 is 2 over 30. You want to take a common denominator, 1 over 10. Is 3 over 30, and 2 over 30 is 5 over 30, or 1 over 6. So 3 and 1/6. If they don't accept this one from you because they want a improper fraction, please understand 3 times 6, 18 plus 1, 19 over 6. That's another way of writing it. It's either way is fine. All right, so we are going to move on. A doctor prescribes a 100 milligram antibiotic tablet to be taken every 8 hours. This is the time step. Just before each tablet is taken, 30% of the drug present in the preceding time step remains in the body. How much drug is left after the third tablet? Write the expression for Q sub n plus 1 in terms of Q sub n. Right away, when we look at this, B changes to Q. I want you to know that. So before we answer any questions, let's write the given. That would be the best strategy when you solve application problems. So what is given? B sub 0 changes to Q sub 0 equals A. It's always 0 in the case of patients unless otherwise mentioned. The amount of constant C is 100 milligrams of antibiotic, and what remains in the body is R equals 0.3. So that's the given. How much drug is left after the third tablet? Let's make up a table, and the first one is 100, of course. Q sub 1 is 100. Q sub 2, it's the same 100 because we're adding 100, and then 30% of that is 0.3 times 100 is 30. They add up to 130. Q sub 3, again, 100 is the constant. So 100 plus 0.3 times this number, which is 39, they add up to 139. Write an expression for Q sub n plus 1 in terms of Q sub n. We use this and we change the B to Q. Then you don't have to do anything. Just go back to the given. That's what makes life easy. Just plug in, replace the R with 0.3, C with 100, and you're done. And I hope you realize if you try n equals 1, 2, 3, you get the table. What about Q sub n? Find the formula for Q sub n. Look at this formula, B sub n. We change the B to Q, that's all. Change the B to Q, everybody. Go back to the given. Replace what you need with the given. Q sub 0 is 0. Lowercase c is 100, and R is 0.3. This goes to 0. This is 0.7. Put it under 100, and you get 100 over 0.7. And we better change it to 1000 over 7 because we need to multiply. We can't have a decimal in the denominator, so we multiply the top and the bottom by 10. And the main reason we do that is for the final step of limiting. Use part C to find Q sub 3. Please understand, over here, you can try 1, 2, 3. Over here, you can also try 1, 2, 3, because 1 Q sub 3, if you plug in 3, you must get the same answer 1/3. I highly recommend you do that. Finally, what is the limiting value? That means take a limit, and that's why we put it in this format, so it becomes easy to take the limit. Let's use the limit laws and separate them into two pieces. Obviously, this is 1, and this one goes to 0. Because 0.3 is between -1 and 1. So the answer is 1000 over 7. And if you want a decimal, this is exact, this is a decimal representation. You always go with exact unless otherwise mentioned. 142.857 milligrams, always answered with the proper units. What does it mean? Therefore, regardless of how long the treatment continues, the drug concentration will never exceed the limiting value of 142.857 milligrams. And they have calculated this to be safe as far as the patient is concerned. That's the idea, everybody. That's the idea of the limit. We want to find the limit, and how do we do that? To find limits, just plug in. If you get a number, you're done. 0 over a number is 0, is you're done. A number over 0 is infinity or negative infinity. You have to figure out the sign. However, in calculus, most of the time we get the indeterminate form of 0 over 0, infinity over infinity, or infinity minus infinity, which requires your algebraic technique. So here, if I plug in, I get infinity over infinity. Because this is a rational function, and because t is approaching infinity, we divide by highest degree term in the denominator, namely t squared, and we simplify. When we do so, this goes to 0, everything goes to 0 except 1. So this is 0 over 1, which is equal to 0. And I want to emphasize the denominator is some number. It doesn't matter, 1 or any other number. The numerator is 0. Therefore, the answer is 0. Same thing happens here. You plug in, you get infinity over infinity. You have a fractional format. T is approaching infinity. You divide by highest degree term in the denominator, namely t. You simplify and you plug in. If you plug in, this is infinity plus 2, this goes to 0, this is 5, this goes to 0. Now, infinity plus 2 or plus any number or minus any number is infinity, divided by any positive number, it is still infinity. And that's the key, division by a positive number, everybody, okay? What about this one? If you plug in, you get infinity minus infinity. And because you have a square root, the technique is a conjugate. As you recall, the conjugate of a minus b is a plus b. The product is a squared minus b squared. So the conjugate for this one, you write the same thing and you change this sign to a plus sign. And not only you put it at top, you also put it at the bottom because this fraction must be 1. So if you extend this fraction bar, so it's the product of these two, a minus b, a plus b, the product is a squared minus b squared, that would be the numerator. These two cancel each other. And now if you plug in, the denominator is infinity plus infinity, which is infinity, and the final answer is 0. To find the limit, we plug in. E to the power of minus t as t approaches infinity becomes 0. Why is that? The negative exponential indicates a to the power of minus m is 1 over a to the power of m. So e to the power of minus t is 1 over e to the power of t, and it becomes 1 over e to the power of infinity, or 1 over infinity, or 0. The answer is 12 over 4, or 3. This expression, if you plug in, the numerator is infinity, the denominator is negative infinity. Because of this one, okay? And although it's not a rational expression, a fractional format, we follow the same as a rational expression. Because t is approaching infinity, we divide by highest value in the denominator, which is e to the power of t. We divide everything by e to the power of t and simplify. As we do, when t approaches infinity, this goes to 0, this goes to 0, we get positive 1 over negative 3, which is negative 1/3. What about this one? Plug in, you get infinity minus infinity. Technique, factoring. Factor the x out. Plug in, infinity times infinity minus 1 is also infinity. The limit of x squared plus x over 3 minus x as x approaches infinity. Plug in, you get infinity minus infinity. Again, this causes it to go to negative infinity. Rational expression, x is approaching infinity. You divide by highest degree term in the denominator. Over here, we see the highest value because it's not a rational expression. So divide by x and simplify. As x approaches infinity, this is infinity, this goes to 0. Infinity plus 1 or minus 1 or anything is infinity. Infinity minus 1 billion is still infinity. When you divide by a negative number, it changes the sign, minus infinity. Section 2.3, limits of functions at finite numbers. Given the graph of the function, state the values, if they exist, of the following. We are interested in limit of g of x as x approaches to, reminding everybody of one-sided limits. A function has a limit at a, if. Limit of f of x as x approaches a from the left and right is the same thing, and it's equal to L. Because we want this one, we're going to look at one-sided limits. So let's approach 2 from the left, which means we are going this way in this branch towards this hole, having the y coordinate equals 3. Let's approach 2 from the right, that means we are in this branch. That means we are going towards this hole, which has a y coordinate 1. Because the two are not the same, the limit of g of x as x approaches 2 does not exist. We are interested in the limit of g of x as x approaches 5. Again, we're going to look at one-sided limits. So as far as 5 is concerned, both sides of 5 seem to be moving towards the same hole, which has a y coordinate 2. Therefore, the limit of g of x as x approaches 5 from the left, 5 from the right, and therefore the limit of g of x as x approaches 5 is 2. So the limit does exist. Now, what do we notice? Assume this one is 1.4, so g of 5 is about 1.4, which is not equal to 2, which still makes it discontinuous
These
at
things, how do you make them
x
not like
equals
noise
5.
canceling? You have these? Yeah, you do. Yeah. How do you do it?
I can't believe this. Also, g of 2. At 2, we don't have a solid point, so g of 2 is undefined. Definition of a continuity, limit of f of x as x approaches a is f of a. So g of x can be continuous at x equals 5 if we do what? Look at number 5, there's only 1 point missing. We can connect them, and if we redefine this, that is called a removable discontinuity. We can fix it. So if we redefine g of 5 as 2. However, there is a jump at 2, and g of 2 is undefined, and even if it's defined, it makes no difference. There is nothing we can do to fix a jump. This is removable discontinuity. This is a jump. Vertical asymptote has a specific definition. X equals a represents the equation of a vertical asymptote if the limit of f of x as x approaches a, or from the left or a from the right, is positive or negative infinity. So we want the limit of the function as x approaches 2. So we approach 2 from the left and right. In both cases, it's going down to negative infinity. Limit of the function r of x as x approaches 5 from both sides of 5 goes up to positive infinity. As we approach negative 3 from the left, it goes down to negative infinity. As we approach negative 3 from the right, it goes to positive infinity. All of them can give rise to vertical asymptote in the following manner: x equals 2, x equals 5, x equals negative 3. This one gives you the same thing. And so we have vertical asymptotes x equals 2, x equals 5, x equals negative 3, and this is from left to right, x equals minus 3, x equals 2, and x equals 5. We continue with taking limits, and obviously the first step is to plug in. When you plug in 1, you get square root of 4, which is 2 minus 2, 0 over 0, and the technique is to do your algebraic technique. In this case, because the square root is involved, you multiply by the conjugate. The conjugate of a minus b is a plus b. So the conjugate of the numerator, you just change the minus to plus. And of course, you put the same thing in the denominator for a simple reason, and that is this fraction must be equal to 1. So when you multiply these two, you get square root of x plus 3 squared minus 2 squared. So you get x plus 3 minus 4, which gives us x minus 1. As far as the denominator, we never ever touch the denominator. We keep it as a product. Therefore, the common factor of x minus 1 will be dropped. And now if you plug in 1 and 3 is 4, square root of that is 2, 2 and 2 is 4, so 1/4 is the final answer. Again, I'm looking at these two questions at the same time because I want you to compare and contrast. Please understand, if you ignore 6 from the right or left, the numerator is 6, the bottom is 0 in both cases. And it makes no difference for the numerator because number 6, whether you approach it from the left or right, is very close to 6. From the left, 5.9999, from the right, 6.0001. It makes no difference. Every number, both sides of the number have the same sign. Positive is positive, negative is negative. The only number that the left side is negative and the right side is positive is 0. And that you have to pay attention to. When you divide a number by 0, we used to say undefined, but now it's either infinity or negative infinity. And so we pay attention to this for the denominator. 6 from the right, example, 6.1. You can even write 7 minus 6. So it's 0.1, meaning we know it's from the right, and it makes it 6 over 0 from the right. And that's really the key. Whereas the bottom from the left, like 5.9 minus 6 is minus 0.1. So 6 over 0 from the left. So both of them go to infinity, but this one is positive, this one is negative infinity. And that's what you need to pay attention to, everybody. Limit of natural log of x squared minus 16 as x approaches 4 from the right. You plug in, you get 16 minus 16 is 0. But since 4 is from the right, then this is larger than 16. So this becomes 0 from the right. What's the answer? I remind you of the graph. If you look at the graph of the function, you can see natural log of 0 from the right goes down to negative infinity. The graph will help you answer the question. Over here, if you plug in, you get 0 over 0. And you plug in minus 5. The technique is factoring. By the way, x approaching minus 5, that means it has to have a factor of x plus 5. A squared minus b squared is a minus b plus b. We factor the top and the bottom, and we get rid of x plus 5. And if you plug in minus 5, you get minus 5 in the numerator, minus 5 minus 5, minus 10 in the denominator, which is positive 1/2. What about this one? If you plug in 3, you get 1/3 minus 1/3, 0 in the numerator, 3 minus 3, 0 in the denominator. This is a complex fraction. The technique is LCD. You multiply the top and the bottom by 3x. So when you multiply the 3x by the numerator, you get x minus 3, and the bottom, you keep it as a product. You drop the common factor of x minus 3. You get 1 over 3x. And if you plug in, you get 1 over 9. The limit of the square root of 2x squared plus 16 as x approaches 0, if you plug in, you get square root of 16, which is 4. In other words, you plug in, it works out, you're done. The limit of x squared minus 6x over x minus 3. If you plug in 6, you get 6 minus 3, 3 in the denominator. And this one is 6 squared minus 6 times 6 is 0. And 0 over 3 is 0. You're done. You don't have to do anything. If I plug in 0, square root of 49, 7 minus 7 is 0. 0 over 0. Indeterminate form. I have a square root. And I'm going to put the conjugate. Because a minus b, a plus b, the product is a squared minus b squared. I put the same thing with the plus sign at top as well as the bottom. And so the bottom is the product, and we keep it as a product. We don't distribute. The top becomes the square root of 49 plus h quantity squared minus 7 squared. We cancel those two. 49 and negative 49. We cancel the h. And now if I plug in 0, I get 49 inside the radical, comes out as 7 and 7, 14, 1 over 14 is the final answer. The limit of 3x squared plus 11x minus 4 over 2x squared plus 11x plus 12, as you working here, if you plug in, you get 0 over 0. Now you need to factor, and that's actually a very easy factor for a couple of reasons. Number one, this is 2, which is a prime number, x and 2. This is 3, it's a prime number, x and 3. So this would be x and then 2x here. This would be x and 3x here. Number one. Number two, if x is approaching negative 4, then it has to have a factor of x plus 4 in the denominator to give us the 0. Happen to be the same thing for the top. And so all you have to do, if you divide negative 4 by 4, that means you need negative 1. If you divide 2 by 4, that means you need 3. Not only that, you want to do the middle term. So 4 times 3, 12x minus x is 11x. 3x plus 8x is 11x. And you drop the common factor of x plus 4. Now, if you plug in 3 times negative 4, negative 12, negative 1 is negative 13. 2 times negative 4, negative 8 plus 3 is negative 5. And negative over negative is positive. Derivative and rates of change given y equals f of x and point PA comma f of a, the slope of its secant line PQ, or the average rate of change. Rise over run. M of PQ is delta y over delta x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you look at these two pairs, f of x minus f of a over x minus a. And if you look at this case, where this one is a f of a, then you go to the distance of h. So this is your run, and this is a plus h. So this is f of a plus h minus f of a, that's the rise. And all of them are referring to the same thing, rise over run. If we go with b and f of b, we get f of b minus f of a over b minus a. My point being, they all mean the same thing. Good old slope. Now, as q approaches p, pq is the secant line because we have 2 points. As q approaches p gives rise to a line known as the tangent line. The tangent line is the limiting position of the secant line PQ as Q approaches P. Slope of a tangent line, also known as instantaneous rate of change, follows that the limit of PQ as Q approaches P. If you go with this one, limit of f of x minus f of a over x minus a as x approaches A. And if you go with this one, limit of f of a plus h minus f of a over h as h approaches 0, which we call it also f prime of a. These are equation of lines, standard form. Ax plus byc, point slope, y minus y1 equals m times x minus x of 1. Slope intercept form, y equals mx plus b. To come up with the equation of a tangent line at this point, we are going to go with the point slope y minus y1 f of a. Let's go with this one, but this is the tangent line, doesn't make any difference. Y minus f of a equals m, which is f prime of a, x minus x of 1, which is a. Again, this is the equation of a tangent line. Do you have to memorize it? No, just use the point slope from elementary algebra. You will get to the same answer. Now, we want to find an equation of a tangent line for the parabola y equals x squared at the pair 1, 1. You need two things. You need the pair it's given, and you need the slope. You have to calculate it, in this case, using one of those formula, noticing A is the x coordinate and f of x is given as y, or f of x equals x squared. We use one of those formats, limit of f of x minus f of a over x minus a as x approaches a. We're going to use this one. So m is f prime of 1, limit of f of x minus f of 1 over x minus 1. F of x is x squared, f of 1 is 1 over x minus 1, and if you plug in, you get 0 over 0. The technique is factoring. Obviously, we're going to use a squared minus b squared because x squared minus 1 squared, we get x minus 1x plus 1 in the numerator. These two cancel each other. Plug in and we get 2. Y minus y1 equals m times x minus x of 1. Plug in. Y equals 2x minus 1. And we are done, everybody. Now, we are done with that, but for practice, as we did it in class, I want to go with the second method as well, which means we are going to use this one. And bear in mind, for this exam, you must use the definition, not the easy way out, which is coming up. So the limit of f of a plus h minus f of a over h as h approaches 0, where a is 1. So f of 1 plus h, if you put it in here, you get 1 plus h squared. And so using a plus b squared, which is a squared plus 2ab plus b squared, this becomes 1 plus 2h plus h squared. 1 and negative 1 cancel each other. We have a common factor of h in the numerator. We can drop the h. And now if you plug in, you get 2, and that's exactly what we got here. And of course, that was the purpose. This was basic math, elementary algebra, not a big deal. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. For what is the average velocity of the object from 2 to 4 seconds, as I've been saying. Anytime they give you 2 points in time, or 2 points in general, that means average, the good old rise over run, in this case, s of 4 minus s of 2 over 4 minus 2. So that is elementary algebra. So you're going to plug in 4, you're going to plug in 2. 2 times 4 squared minus 5 times 4 plus 4d. and then minus s of 2. 2 times 2 squared minus 5 times 2 plus 40. And this is 16 times 2. 32 minus 20 plus 40. This is 4 times 2, 8 minus 10 plus 40. And we get 52 minus 38, which is 14 over 2, which is 7 feet per second. This part is basically elementary algebra. What is the instantaneous velocity of the object after 4 seconds or at 4 seconds? When they give you 1 point in time, that is instantaneous, and that is taking the derivative. The v of instantaneous is s of a plus h. So that means s of 4 plus h minus s of a, s of 4 over h as h approaches 0. Now we have to evaluate the numerator. So plug in 4 plus h here. You get 2 times 4 plus h squared minus 5 times 4 plus h plus 40. S of 4, you can do the same thing. Or remember, S of 4 was calculated as 52. That makes it easier to use. Please understand, the hardest part is to do the algebra here, which is tedious. It's not difficult, it just takes some time. As you know, a plus b squared is a squared plus 2ab plus b squared. So this is 16 plus 8h plus h squared. When you distribute the 2, you get 32 plus 16h plus 2h squared. When you distribute the negative 5, you get minus 20 minus 5h. This is plus 40 minus 52. And you start with the numbers, and you notice 32, negative 20, positive 40, negative 52, they all add up to 0. The numerator has 16h, 2h squared, and negative 5h. These two add up to 11h. So 2h squared plus 11h, you factor out the h. And now if you plug in, you get 11 feet per second. You must answer with proper units always. Continuity. G of x is half of x plus 3 for x less than negative 2, and x minus 1 for x larger than or equal to 2. And we are checking to see if G is continuous at x equals negative 2, why or why not. First of all, reminding you of one-sided limit. The limit exists if one-sided limits are the same. Continuity means the limit of f of x as x approaches a equals f of a. That means the limit exists. That means the functional value exists, and they are equal. Why are we checking out at negative 2? As I mentioned previously, this is a line y equals 1/2 x plus 3. Domain is all real numbers, therefore continuous from negative 2, from negative infinity to negative 2. This also y equals x minus 1 is a line continuous from negative to positive infinity, which makes it continuous from negative 2 to infinity. However, the end unit, that means negative 2 must be checked, and therefore we are going to look at 3 things. First, we start with the functional value. Wherever the equality is, we are going to use this piece. This is a piecewise defined function. Plug in negative 2, and you get negative 3. That's the function value. So we are checking the end point number negative 2. Let's look at the left side limit. That means you look at the less than piece. So this function, if you plug in negative 2, you get negative 1. 1/2 of negative 2 is negative 1, and 3. They add up to positive 2. Now the right side limit, greater than, you look at this piece, x minus 1, and you plug in negative 2, and negative 1 becomes negative 3. As you notice, the limit from the left and right have different values. The limit doesn't exist. So the limit of g of x as x approaches negative 2 from the left is not equal to the limit of g of x as x approaches negative 2 from the right. They're different. Therefore, the limit of g of x as x approaches negative 2 does not exist. That means g of x is not continuous at x equals negative 2, or you can say it's discontinuous. Now, is g of x continuous at x equals -2 from the right. Notice the functional value and the limit from the right are the same, so the answer is yes. Nevertheless, the function is still discontinuous at x equals -2, but we say it's continuous at x equals -2 from the right.